Hello everyone. So what I wanted to go over today was how to find the greatest common factor of an expression with variables and numbers. This lesson is going to help you when working towards factoring out the GCF. So first, I just want to let you know I organized each question into a graphic organizer to kind of help organize the way we solve these. So the directions state to use the prime factorization method to determine the GCF of each of the following. Well, first we need to recall what the GCF means. So GCF stands for our greatest common factor. And we know that factors are numbers that, when multiplied together, can give us a specific number. So we need to find the greatest common factor of each of the three terms in each expression. So if you look at number 1, we have the expression 2x squared plus 4x plus 16. So our goal is to look at each of the terms and find the greatest common factor by breaking them down into factors. So here's each of our terms. Okay, so let's break these down. So prime factorization method is just using, a lot of kids look at it as like a tree with branches coming out. So we'll take 2, for example, to start off with. So 2, the only numbers that multiply to get 2 are 2 and 1. So that's already a prime number. Next, we have to look at the variable. So we have the variable x to the second power. So what x to the second power means is that we have x times x. We have 2 x's. So in order to factor that, we need to write 2 x's. So our prime factorization of our first term is 2 times x times x. Now let's move to the middle. We have 4x. To break down the 4, we have to think of numbers that multiply to give us 4. So for example, 2 times 2 gives us 4. Then we have to look at the variable. We have only one x here, so we just bring down the x. So our prime factorization here is 2 times 2 times x. Now we're going to move on to the third term, 16. We don't have any variables here, so we're just going to break down the number. So we have to think of 2 numbers that multiply to give us a 16. So off the top of my head, obviously you can use a calculator if you need, but off the top of my head, I think of 4 times 4. Now, is 4 able to be broken down anymore? I think so. So let's break down 4. What 2 numbers multiply to give us 4? I know, 2 times 2 gives us 4. We're going to break down the second one as well. 2 times 2. So our prime factorization of 16 is 2 times 2 times 2 times 2. All right, now it's time to find the GCF. So let's look at all 3 of our prime factorizations of each of the terms. We have to look for what they have in common. So let's look at the first one. Let's start with the 2. So let's see if the other 2 terms have a 2 in it as well. The middle one does, and so does the last one. Awesome. Now it looks like we can't take out more than 1 2 because the first term only has 1 2. Now let's look at the variables. The first term has 2 x's. The second term has 1 x, and the third term has 0 x's. So since the last term does not have any x's, we cannot take out any of the x's. So that concludes what our GCF is. We only have a 2 in common from each of the terms. So therefore our GCF is 2. All right, now let's take this a step further. We have number 2. Number 2, we have 22x to the third power minus 55x to the second power plus 121x. So it's broken down into 3 separate parts because there's 3 separate terms. So let's do our prime factorization. For 22, think of numbers that go into 22. I'm going to use 22 and 11. Now I'm going to look at my variable. Since it's x to the 3rd power, that means that you have x times x times x, or rather 3 x's. So I'm going to bring down 1, 2, 3 x's. All right. Now let's move on to the middle. We have negative 55x squared. So I'm not going to focus on the fact that it's negative because that's not going to affect my prime factorization. So let's break down 55. For 55, we have 5 and 11. Now let's look at our variable, x to the 2nd power. That means we have 2 x's. So let's write down our 2 x's. Awesome. Okay, let's move on to the 3rd term, 121x. So let's break down 121. So off the top of my head, I'm thinking of 11 times 11. Now, let's look at the variable. We have only 1 x, so we're just going to bring the x down. Awesome. Okay, let's look at what we have in common between all 3 prime factorizations. So let's start with the first one. First one, we have a 2. Let's look to see if we have any other 2's. Nope, it does not look like we have any other 2's. Now let's look at the 11. It looks like we have 11 in all 3 of our terms. Very good. All right. Now, also, in terms of numbers, the middle one has a 5, but neither of the other 2 do. All right. And last, we look at the variables. So our first one has 3 x's, second one has 2 x's, last one has 1 x. So, in common, we can only take out 1 from each one. So therefore, our GCF would be 11 x. Great job. All right. Let's move on to the next one, number 3. All right. Here we have 16x squared plus 12x minus 32. So it's broken down once again into 3 separate terms. Let's start finding the GCF. To break down 16, going to do 4 and 4. We know 4's can be broken down, again, into 2 times 2. 2 times 2. All right, let's look at the variable. We have x to the 2nd power. That means we have 2 x's. So we write our 2 x's at the end. Let's move on to the middle. We have 12x. We know to get 12, we could do 4 times 3 to get 12. And we know 4 could be broken down again into 2 times 2. And I'm just going to bring down that 3 again. And it looks like we have x to the 1st power. So we have 1x, so let's add that to the end. Okay. Last but not least, our negative 32. Let's break that down. Let's do 8 times 4. All right, these numbers can definitely still be broken down. We know our 4 is equal to 2 times 2. Our 8, let's do 4 times 2. And it looks like we still have that 4 to be broken down. So that becomes 2 times 2. And we have to bring down these last 3 2's. Wow, that's a lot of 2's. Okay, let's see what we have in common. So it looks like we have at least 1 2. It looks like we can have 2 2's in common. Yep. Can I take out a 3rd 2? Nope. Because that 2nd term only has 2 2's. There's no more for me to take out. All right, let's look. Also, you cannot take out a 3 because only one of them has a 3 and the other 2 do not. And lastly is our variable. So our first term has 2 x's, Second one has 1x, and the last one has 0 x's. So can we take out a variable? Nope. So those are just going to stay there. So we're going to be taking out 2 times 2 for each one, and we know that 2 times 2 gives us 4. 4 is our GCF. Nice. So this is going to be the last one I do. This one's a little bit different than the others. There's only 2 terms here. We have 40x squared minus 90. We're going to do this the same way we did before, except with only 2 terms. So let's break down this term here. 40. Let's do 4 and 10. We know our 4 can be broken down into 2 times 2. And 10 can be broken down into 5 times 2. Awesome. And we have an x squared. So we know that's going to break down into x times x, or rather 2 x's. Good. Now let's move on to the 90. All right, what makes up 90? Let's try 9 times 10. All right, let's break down these numbers. 9, what times what gives me 9? 3 times 3 gives me 9. And if we break down 10, we get 5 times 2. All right, let's see what we have in common. So let's start off here. It looks like we have a 2 and a 2. Both do not have a 3. We cannot take out any more 2's, but it looks like both of them have a 5. All right, now let's look at the variables. It looks like only our first one has 2 x's and the other one has none. So it looks like we will not be taking out any variables, but our numbers in common are 2 times 5, or 5 times 2, and we know that they both equal, oh, that was an ugly 5. 5 times 2, we get 10. So magical number 10 is our GCF. Okay, I hope this helps. You can use this to complete the rest of your worksheet. And if you have any questions, please let me know.